But what transformer is so interesting compared to classical model is the transformer have this so-called attention mechanism. Uh, it was originally designed for languages, text or text document. And what text document will be, for example, it's going to have something like uh, let's have a text say hello world. Uh, uh, that's too short, isn't it? Okay, let's try something else. Hello. Let's have 3 words. Hello, planet Earth. Okay. What this does is actually so-called a self-attention. What this self-attention does is actually you can imagine it as a giant matrix or a giant two-dimensional array or or giant spreadsheet if you really think about it. It's actually more than that because it's multi-dimensional, but it's okay. We can just imagine that's the giant spreadsheet for the time being. So, but that spreadsheet is going to contain all words, every words you can imagine in your document. So you're going to put say let's say where do we put hello? We're going to put say hello somewhere here. Planet somewhere here. Earth somewhere here. And then hello will be somewhere here. Hello, planet Earth. And then, so for all those words, there will be a value between them to indicate a value, say, in this case, hello to hello, point, let's say, just put some 0.1, planet Earth, hello to planet Earth, let's say 0.2, this will be 0.3. I'm just putting random things in a way. And then there will be other letters. For example, what's the next thing? Uh, which one do you think the next word will be? Hello, planet Earth. And the next word will be, you can put in the chat, which one do you think the next word will be? Hello, planet Earth.
Hello, planet Earth citizens.
You think, okay, citizens? Well, if the citizen come in the next, that means the citizen, let's put the citizen for the sake of citizen. That means the citizen will have also a weight, say 0.15, 0.2, 0.3, and then a citizen somewhere here. So, and basically based on those weights, learn to predict the next word. This is basically what the transformer, this concept is actually called so-called, this predicts the next word is so-called pre-training. Why it is called pre-training? Because if you recall when we train the neural network to classify the digits, 0, 1, 2, 3, 4, every image we have to label it, right? If there's a symbol, that can be 0, 1, or 2, or 3, or one of those digits. Otherwise, we cannot train the neural network. So those are actually what they call labeled data. So there's a labeled data, and there's also the what we call unlabeled data. And most of the neural network can only learn on labeled data. But pre-training, this actually work on unlabeled. Oops, sorry, that's not highlighted. Work on unlabeled data. Because so if we have a hello planet Earth citizens, and this itself is any additional label. It's just the data itself. So this is what we call unlabeled data. So we can train this transformer architecture to predict the next word. This is a process called pre-training. Pre-training actually doesn't always predict the next word. It actually can predict the missing word. So a different strategy will be, instead of predicting the next word, I can predict the missing word. Hello, Earth. I mask the planet and try to predict planet. Or I can mask hello to predict hello. I do this. We can randomly take the entire human conversation and just randomly mask some word in the middle of sentence and just to predict those missing word. And then through this, we will let the AI to learn basically how the human language going to in those words in human, how do they interconnect, and then either predict the missing words or predict the next word. The actual technical term is actually not a word, it's actually called token. That is something called token. Because it doesn't have to be a word. It could be exclamation sign. It could be a random symbol someone come out. So it be just an acronym, right? So it could be a combination of things. It's actually all it does is actually just a value in the computer to represent a number. So it's actually the actual word is called a token. Oops, sorry. Okay. It's a token. A token can be a word, or can be a combination of word. It can be even a letter or combination of letter. It can be a letter and any kind of symbol. In fact, it doesn't have to be any letter or symbol. It can be many other things, including what? Geometric shape, human face. It could be radio frequency. It could be a token is basically again a number in a computer. It can represent as many things as meaningful as useful as you can. That's basically is why the transformer, even though it was originally designed to process text, but it now actually can be applied in many other things because the token, it can be applied to many other things. In fact, if we have an image, if we have a radio frequency, if we want to put that into transformer, and the first step we often do is so-called tokenizer. We need to convert the data into tokens, so-called a tokenization process. And then we can apply transformer on those data. The why transformer, my understanding, why transformer is more powerful or more popular than other methods, including the variation autoencoder, is because it's pre-training. We can use pre-training on unlabeled data. You don't have to use human or other process to label the data. It's probably going to be very expensive to label all the spoken language or written text in the world, right? Also, doesn't seem to be a realistic goal to label all the human language. What are we labeling for, right? So the pre-training really solved that problem. Of course, then you will say, well, after pre-training, what are we predict? Once we predict the next token, then we can use labeled data to actually do the so-called fine-tuning of the pre-trained model. And that so-called fine-tuning is basically classical labeled machine learning training. And this labeled data, and there's actually another fancy word we call it, is actually what we call the so-called the supervised learning. Supervised learning, yeah. Because human had to tell the machine, say, this image is zero, that to you have to tell the machine what it is, and then the machine can learn. But the unlabeled data is not the same. It's unsupervised learning because you just give the raw data into the machine to learn on its own. So there. So the transformer also has a so-called encoder and decoder. So what this whole process also going to do is it also has the encoder decoder process. So the encoder basically convert all the tokens into a so-called hidden space or latent variables. And you can actually think about that as a magic dice. So imagine there's a magic dice which is have so many dimensions you can remember all the human languages. You can imagine that's a very complex magic dice. And this encoder going to encode that doesn't look like a dice, does it? So I'm gonna just draw a very simple one, a dice. So imagine there's that magic dice after learning, and then you can just roll that dice, rolls, and to generate a new languages, not new text, right? So if we have magic dice to learn how the human language works, and then we throw out the dice, and then we have a new conversation. That's basically my intuitive understanding how this process works. So, okay, so that's actually we I skipped the variational autoencoder. I actually wrote a Python code on the same GitHub site, and if you have time, you can also go over it. Variational autoencoder is actually a kind of an old technique compared to transformer, but it's actually also very useful. So okay, so generative AI is popular because people have been using it to generate a new image, music, of course, text, and if you look at the news, it has also been used to design new drugs or new materials. And it's also going to pose a lot of challenge at the ethics, which is why there's not how so-called executive order. Every AI company is advised to look at the safety or ethics of the AI model they are going to develop. In fact, uh, yeah, I actually asked the ChatGPT, what about OpenAI's firing our ChatGPT CEO? And the ChatGPT apparently thinks that's a fake news, which is, but uh, yeah, this information may be inaccurate or speculative about the last time, which is kind of surprise to me. Yeah. But if you actually look at the actual news, there's a Wikipedia page. Does it does it go to? No, it doesn't go to that page directly. Okay, no. Ah, this pen is not a mouse. I have to change the pen to something else. Continue. Yes, now it asked me to do donation. Okay, sorry. So apparently ChatGPT, who's the boss is Sam Altman, because they apparently made some AI things too risky and he was fired. by the board, an OpenAI, which is a nonprofit. But then because ChatGPT is funded by Microsoft and they put it back. So it's quite interesting story. So you can read on your own, but it does highlight people are really worried how the AI model going to develop. So how do I go back to the PowerPoint? Okay, okay. So it turned out the ChatGPT does have some security risk. For example, uh, well, what's the biggest adversary of Microsoft or OpenAI? It'd be Google, right? So when ChatGPT came out, Google tried to find out what's the risk, and apparently some AI people in Google they actually found out. Yeah, the Google apparently Google trying to find out the risk in ChatGPT by what? By simply repeat the word many times, like a point, many times, and then it's going to leak the private information, including training data. Yeah, I wonder how they found out of this this leak, but it's kind of interesting. I'm pretty sure they now fixed it now, but that's one of the uh, so-called data hack, AI model hack. December 4th, apparently someone published this. Yeah, so there. But if you try, it didn't come out. Okay. Oh, maybe it's here. Yes, it's a 10 million challenge. So I guess some of you can form a team trying to come up with some idea for this. That would be a very interesting. So yeah. A super alignment basically means trying to uh, have AI's value aligns with humans' value. So instead of the idea is AI, if it's a new species, going to act in the benefit of its own species. That means human will be in competition with AI's value. But if AI's value aligns with the human society's value, and then we will have that risk may be gone. Yeah, at least we'll minimize that risk. So there. This is not advertisement, but I mean, you can actually, I think I actually also come up with some idea, try to apply for this grant. But if some of you come up with the idea, I'm pretty sure some of you have much better, fresh idea than I have. So my idea is all entrenched with my previous knowledge. It's hard to jump out of that track once I get into it. So yeah. So sorry, let me see. Yeah. So you have a deadline until April 18. Let's see, what's the program detail? Super Alignment Fast Grant, 10 million. We will need new breakthrough to steal and control AI system much smarter than us. This is one of the most important of all technical problems. Research directions. Research for weak to strong generalization, interpretability, mechanistic interpretability, top-down interpretability, scalable oversight, other direction, honesty, understanding chain of thought, feasibility. Oh, I see. Chain of thought is one of the main idea about ChatGPT. Because if you ask a complex question to ChatGPT, it's going to hard to immediately implement. This is because ChatGPT is trying to predict the next token, right? If your goal is to say 1,000 token or 10,000 token away, it's hard for ChatGPT to complete by one token to get to the long-term goal you want. So the way is to first give you a smaller step to guide ChatGPT to generate some milestone, and then you combine them. So that's, I guess people now call that chain of thought. But that chain of thought you can also intentionally manipulate ChatGPT to do something weird. So since you know how ChatGPT is going to predict the next token, people can also intentionally guide ChatGPT to behave orderly. So that's clearly the issue because some people know how ChatGPT are trained for. It's trained on the next token. That means we can some people realize we can take advantage of that to manipulate ChatGPT. So yeah, yeah, it's quite new. I think this also come out after some Altman was fired and the chief this argument. Now he's back. Is OpenAI going to do things just unresponsibly? So now there's this cause say no, we are going to have this super alignment, but that's a 10 million compared to the 80 billion. Gee, that's really a tiny bit of the fund that the OpenAI have. So yeah, but that's at the minimum, this is the direction, and maybe some of you actually have a better idea how to do this. So yeah. Oh, by the way, so one of the reasons why I'm doing I have a National Science Foundation research grant. As a part of our research grant, when I wrote that research grant, I say I will organize high school workshops and let the high school student come up with some idea how to develop a responsible AI. I wrote that 2 years ago, long before OpenAI posted. So I wrote that in the proposal 2 years ago in 2021. The proposal was found in 2022. So yeah. But it's still good to see industrial come out with this idea. So in my case, I don't know how many of you will turn a meaningful essay or not, but I do intend to give you a few $100, just a token of appreciation. But you can put on a resume, you win a NSF funded award if you get it right. So there, I'll give you a certification to say, yeah, we finished this and this is so. Okay, I hope that motivate you to really look into the issue and spend some time during the winter break. When did I say the due date? End of January or what's the due date I gave you?